Hey guys, what's up? It's been a while since my last video, a lot of things going on lately, so finished my contract at ILM and now preparing a bunch of personal project and tutorial while traveling. So coming back with a two-part tutorial about the props modeling, we're gonna see how we can make a setup that allows us to art direct the shape of a torch and its support. It's actually part of a bigger course I am making. This is the picture I'm working on, so a lot of interesting topics to cover with this scene. Hopefully they should be available early next year. In the meantime, let's dive in procedural modeling. So let's start with a tube. You can change the primitive type to polygon, tweak the height, rows and columns. So that's going to be the very basic shape. Then what we want is isolate the edges, the vertical edges, so we can use the minimum edge angle to group that. So now what we can do is create a peak, and it's gonna push the polygons based on the normal direction. So we're basically gonna mix the two states before and after the peak. To do so, we want to use an import point attribute, and the attribute is of course P, and we want to import the position from the first and second input. When we do that, I'm using a mix node, so if we change the bias, we see that it's like switching between the two positions that we set. So now we want to extract the y-axis with a vector to float and actually feeds up into a spline so that we can reshape everything. I'm just going to call it height deform. So if we tweak the spline, it's not really working because what we need is a relative to bounding box. So this node basically gonna use values between 0 and 1 for the position, and now it's like properly working when we try to tweak the spline. So this is actually gonna be the top of the torch. So we can try to find a shape that looks kind of cool. Can also change the interpolation to b-spline so that we got some more curves going on. So it's just trying to find a cool shape, and if you need, you can also go back to the peak if you went not enough or too much into the normal direction. Right, let's say we are happy with that. We can poly bevel this guy and use the edge group we defined earlier. It's changing the division to 1, and now we can blast the bevel primes, so don't forget to check the bevel prime in the poly bevel. So that's pretty sweet. If we try to change the columns, it's perfectly working. So there would be multiple ways to achieve this shape really, but personally, that's what I prefer for now, so let's keep going. We want to use a for each connected primitive now to go through all of those planes. The first thing we need to do is to procedurally select the highest point of the object. So I'm using a group expression that I change the type to point and call that top point. So if we copy the parameter of the height, we can use that to drive the expression. So let's say at p.y smaller than the tube height, multiplied by 0.5 because it's centered, right? I subtract that with a little number just to give some room. So trying to change the height, looks like it's not working. Need to reset the cache, but yeah, seems like it worked. It worked fine. Okay, I'm using a soft transform now. We want to scale those points, so I'm calling the group top point and change the scale. So the scale is a bit messed up, so we're gonna use the pivot translate $GCX, GCY, GCZ to center the pivot to the center of the group selection. And what's cool is that we can use the soft radius to give some feathering kind of thing going on. So that's pretty sweet. You can always go back to the tube and add more or less rows if you need more precision and stuff. let's extrude that guy, and don't forget to check output back so that we got a proper thickness. Now we don't want the edges to be that sharp, right? So let's add a poly bevel, and we want to increase the offset. So we see there is a lot of unnecessary bevel that we can get rid with ignore flat edges and crank up the flatness angle. Yep, it's looking better. We can change the type to round and decrease the subdivision, or increase it if you need. So I'm pretty happy with that for now. Let's isolate the bottom edges now. So this time we're gonna go at bottom edges and use the normal to drive the selection. So I'm putting that to -1 and reducing the spread angle, because we see that the normal are pointing down will be isolated. So that's great. We can now call this group into a poly extrude and increase the distance. So it's going into the normal direction, but if we want, let's just change the gizmo to global and increase translate Y so that we got something more flat going on. Yeah, and we can always adjust the distance. Yeah, something like that. I'm pretty happy so far. So it's looking like this. So let's clean a bit and apply some colors just so we remember the key feature of the setup. So what's great is with this setup we can always come up with some new design by tweaking the point of the spline, and yeah, we can iterate very easily on the shape. So that's pretty cool. There would be, of course, like many ways to do that, I guess, but I kind of like using splines. So now that we are happy with the shape, we're gonna work on the inside rings. Let's drop a tube again, and this time, well, let's change it to polygons and add more division into the columns. And we're gonna use the match size node, which is a very versatile node that allow you to fit the transform of a source to a target. So let's say I'm justify the minimum position to the top of the torch, and now we got this inside piece that's gonna link everything together. So I'm tweaking the height for now, and we can of course add the caps. Now we want to extrude a little bit and give some more shaping. So on the cylinder you see there is always 0 and 1 for the bottom and top faces of the caps. So let's just call the bottom face with 1 in group and tweak the distance and inset. Yeah, something like that. Can also use a transform like to give a little bit of offset so that it's not so aligned perfectly. So let's say -0.05 looks okay. Let's not forget to export the extrude front and call this group into a new poly extrude that's gonna shape the handle. Some more tweaking, and we can increase a bit more the distance for the length of the torch. Yep, instead 0.1, give some nice taper. Let's not forget also to add some color so that we remember the key control, and export the front groups, this time extrude from 2, and blast this extrude from 2 to isolate the bottom face. So I'm adding a null so that we start to organize a bit more and call that output handle. Let's give it a blue color so that we know it's an important thing. So it's looking pretty sweet. Let's add a sphere. So we are basically converting the bottom face into a sphere, and we want to be able to scale it. So let's add a transform. Now the thing is, as soon as you increase the size, you need to center it with $CEX, CEY, CEZ into the pivot translate, and now we can scale it properly and it's still fitting the bottom of our handle. That's wonderful. So if we try to give some variation to the length, it's still following the handle. So that's great. Let's add a green color to the node so that we may remember later that we want to tweak the size of the sphere. So now the polygons of the sphere, we might want a polygon mesh and maybe tweak a bit the columns, rows. I'm basically going to copy the parameter of the tube we had for the handle and copy it so that it perfectly match. Now the problem is not totally matching because the sphere is not completely well centered, so I'm just using a match size to refit everything to the proper place. So now we see that the edges are aligned properly, and we're gonna, instead of a merge, make a boolean to try to merge this object together. So we want a union, so it's looking pretty sweet. We could tweak the rows to find a better spacing. That seems to work. Now in the boolean you may want to output some groups like A, B seam and B outside A. I'm going to show you in some situation you can use A, B seam to add a bevel. Right now it's like, I think some points are not fused properly, I think. So instead we're going to use a blast and blast B outside A, delete non-selected, and group the unshared edges. I'm going to call that bevel and check unshared edges. So what we want to do is transfer this group to the boolean that we have. Group transfer, and let's make some room, clean some connection. Yep, it's looking a bit more organized, I think. So in edges group, I'm calling the bevel group we just created. And if we try a poly bevel now and call bevel, it's now working well. There's some weird stuff because we need to tweak the distance threshold. And also I forgot, we need to fuse the points. Yeah, it's looking a bit better. So now we got a proper bevel that connects the sphere and the handle properly. It's looking cleaner, I think. Yeah, and if we change the distance, it's always seems to work. So in a procedural setup, it's always important to make sure that everything you tweak is still working in any situation, right? So let's go back up there and add a null that we're going to call output top, I guess. I'm going to drop a line that we're going to fit to the top of this torch. Let's scale to fit. So now we got a line that perfectly fit the bounding box of the top. So this null is going to be called output rings. Yep, that sounds about right. So we're going to use this line to drive the position of the rings. We can use a curve to control the range of the position. So if we check second view and tweak that, we see that it's like trimming the line, so that's great. And let's try to drop a copy and plug the tube that we had before. So we see that it's like copying the tube to the points of the line now. I'm just gonna make its own primitive and remove the caps of the, can scale the radius to fit a bit more the rings and add a bit of height, I guess. So you see, as soon as you change the curve node, it's changing the position of those rings. Well, that's pretty cool. Let's add a bit of thickness, so we drop a poly extrude and tweak the distance. So when the faces are blue, it means the normals are reversed. So we may want to drop a reverse node to get the proper normal orientation. As usual, let's drop a pulley bevel and add a bit of offset. Let's get rid of the unnecessary bevel with ignore flat edges, sorry, and tweak a bit the offset. So I'm gonna keep it to chamfer and just with one division. Yeah, it's looking pretty sweet. I mean, it's doing the job. Cool. Let's make some room and push this node to the left. I think this will help. And okay, this is all rings. We're gonna make another poly extrude, this time with a positive value. And we wanna try to group the intersection of this poly extrude with the rest of the torch to define the position of the bolt. So I'm gonna connect the group like so, and we need points because when you use bonding objects, you only need points, right? So let's just call that bolt, and we're gonna convert this group from point to primitive. This way we'll be able to extract the center of every face. So let's just get rid of the unnecessary faces like so, and I'm using an assemble node and create packed geometry to create a point at the center of every primitives. With the add node, you can just check this line and it will remove the primitives. So now if we try to drop a copy and a tube that we're gonna call bolt and apply color, so that's an important stuff. Let's add some cap and change the orientation. So it seems to work, but the orientation is a bit messed up right now. Yeah, but at least we see that it's copying at the center of the intersection, so that's great. We're just gonna use an attribute transfer to transfer the normals of the torch. So just reorganizing a bit. Yeah, hopefully it's not too confusing. Okay, so in the attribute transfer, we want the normal, and of course we need a facet to compute the normal that we had and change the orientation to z-axis. So the thing is, it's hidden behind the ring, so let's just add an extrude there. Yeah, let's just add an extrude and disable output side so that we just keep the... Actually, we could have use the peak node as well, but yeah, whatever. Let's just use that for now. So the bolts are a bit big, so let's just adjust the radius. Sweet. Let's apply some color to the important stuff again. And now if you change the carve, the bolts are following the rings, so that's pretty cool. We might want to bevel those bolts. Of course, you're free to import your own bolts or create some yourself. I'm just going to do something very basic with a bevel. Yeah, looks all right. Yeah, I guess that will do the job. Okay, let's move on. Let's drop a normal so that we see a bit better the shapes that we defined. Cusp angle to 40. Every faces with an orientation under 40 is gonna be smooth. Okay, we're gonna work on a strap or something for the handle. So let's make sure first that we export the extrude side group into the handle extrusion and blast the extrude side face and delete non-selected to just isolate them. And we're gonna fit a line on that guy. So let's just drop a line and match the size, right? Scale to fit. Awesome. We could as well drop a curve node if we want to control the position of the curve. Yep. It's gonna trim everything properly. And because we're gonna create an helix shape, we're gonna need a lot more points. So let's add a resample and tweak the length. Now to create the LX, I like to use the point node. As you see, it's got a bunch of expression already pre-made. So let's use this one and click on the plus to generate all the controls. And okay, let's start tweaking stuff, add some height, radius, and we wanna flatten the spline so that it's going straight, and tweak a bit the radius, and of course add a bit more points so that it can fit all the spiral turns that we had. Okay, it's looking cool. Now the thing is, it completely changed the size of our line, so we're gonna use a match size again. Okay, let's just plug it there. Okay, so now you see that it's centered on our line. Now the thing, it's not exactly refitting it properly because there's no bounding box, but that's okay. We could just control it as is, and we're gonna project the points with a ray node. Let's move a bit things around. Okay, so as you see, if we project points onto the handle, we need a minimum distance to fit this helix shape to the handle. Now it's look a bit low res. I think we may want to add a bit more points maybe. And let's tweak the height again. I'm applying some colors again. That's gonna be some major control. And let's drop a poly wire to mesh this guy. So I'm gonna apply a very thin radius of 0.016 for now. Creating a node that I'm gonna call output wire, and plug that into the merge. Okay, so it's hard to see what's going on. Maybe we should apply some color to the mesh. So I'm gonna apply like kind of brown color to this mesh. We could as well increase the wire radius a little bit, and let's see, maybe more turns. Okay, if we start playing with the curve, it's controlling the position. Now the thing is, the ray node is doing too much of a good job, so let's add a peak node before the ray so that we give a bit of room for the wire. Yeah, something more like that. Looks kinda low res, so let's try add some division. And tweak the length of the spiral again. It's looking way better, I think. Yeah. Okay, one thing we could do is add some randomness. Well, that's a lot of randomness. So let's drop the scale of the point jitter to something like 0.01, and yeah, it gives something a bit more organic, I guess. Okay, maybe the top could be thicker, I guess. Let's delete that, and onto this tube I'm gonna increase the radius scale, so we've got a thicker handle. Maybe not that much. And let's tweak the inset so that the handle got thinner. Okay, so we're gonna add some more detail on that, guys. So we want to first isolate the top face. So a group named top face, normal direction is gonna be the one pointing to the y-axis. So let's be careful not to select the sphere. So we can reduce spread angles and should be fine. Let's just drop a poly extrude, and we call in it top face. Increase the distance, the inset as usual, and yeah, it's looking okay. Let's export the side group, and we're gonna call this side group into another poly extrude, do some inset. Oh, it's also extruding the bottom because it's kind of overriding the group name. So let's just call this extrude side 2 so that there is no confusion. Sweet. Let's move some stuff and reorganize. So this is torch handle, has to be blue, and let's put some blue everywhere actually. So this one is torch top and torch bolt. Okay, just like to clean as I go, otherwise it's gonna be too confusing. Let's now work on the fire tank. So delete node over there, and we just keep the bottom point called 0, and add a copy node where we basically copy the same tube. Okay, then again we center the pivot with $CEX. Let's do some shaping and add a polyfill. So I think I'm just gonna keep it single poly. And that's gonna be torch flame tank that we plug to the final merge. Gonna create a color so that we see it a bit better on the bolts as well. So that's gonna be an important parameter. Let's just change this expression to $ymin, which is basically shifting the pivot to the lowest point of the object. And we're going to delete the top face. So in that case, the numbers are not working like it used to. So let's just use a normal direction to delete it. Okay. We're going to add a bit of thickness with an extrude. Output back. And apply the proper normal with a reverse. Now we're gonna group the bottom face, so -1, call that bottom face. So as usual, we can delete the unnecessary faces with a blast, like so. And let's extrude a little bit, but just with an inset to get a ring and uncheck output front. So that's going to be a group for the support. With the group range, we can select a certain amount of primitives. So that's pretty sweet. Let's blast again the unnecessary faces and extrude. Let's give a bit of distance and let's export the front group. This time we're gonna just rename it and call that face to project, because we're gonna project that. To project that, well, we're gonna use this guy. So we can use array. Now I don't like crossing connections, so we could use an object merge to call the same object, the torch handle. Sweet. So on that guy, we want to use the minimum distance and just project face to project. Now that seems to work. If we try to change the shape of the handle, it's actually following, so that's great. But we don't really want to have this kind of weird stretch, so let's decrease the size of the support. Yeah, I guess that would work better. Alternatively, we could also maybe blast the top face of the handle and scale it a little bit, so we're gonna cheat. As usual, if we want to scale the circle, let's center the pivot. And when we check out the projection, it's now projecting on a flat surface, which help a lot. Okay, so this is what we've been doing. That's great. The flame tank is a bit small though, so we could just increase the uniform scale now and give some more like scale Y to stretch it a bit. let's expose the group range in green so that we remember where to find stuff. We may want to poly bevel this guy too. That could help. Oh, that's some weird stuff going on, but yeah, better. Boop, boop, boop. So yeah, feel free to play with the bevels and see if you get something cool. Let's output the back two into the support extrude. So that's pretty much it, guys. With all the green that we exposed, we could tweak them and try to get some other designs. So this is the result I got when tweaking this setup. Now we're still gonna need to work on the support of the torch in the next part of this tutorial. For this render, shading wise, I used the tool developed by my friend Roman Choliak, known as Wizix. He's been developing a procedural shading library tool for Arnold and Maya called Shade It. It's really awesome and you get sweet results very quickly. I'm adding a link in the description if you want to check this out. And that's pretty much it for today. Thanks for watching. You know the drill. Please like and subscribe. And please show me your result. I'm always excited when you share what you did either on Instagram or Facebook. You got my contact in the description. So see you in the next part.